Winds up to 60 miles per hour in the mid-Atlantic and isolated storms in the central plains and Midwest. Good morning, I'm meteorologist Pew. Today is July 8th, 2025. Our main concern today is winds up to 60 miles per hour. And we can see that we have a 50% chance in the mid-Atlantic and a 5% chance surrounding that and in the Midwest and central plains. There's also concern for isolated small hail in the central plains. Starting in the Northeast, we can see storms start to develop as early as 10 a.m. Eastern time in western Pennsylvania. And then the mid-Atlantic and East Coast can start seeing stuff around 19 to 20 Z, which is 3 to 4 p.m. Eastern time. Taking a look at the satellite imagery, we can see we have clear skies in all of the concerned areas that we're looking at today. But something else that I want to point out that's actually really cool, if we look at Missouri right now, we can see an outflow boundary layer that's coming out of residual MCS or mesoscale convective system, or what I call big blob from last night. And this little outflow boundary layer may influence any convection in those areas because it's kind of like a little premature frontal boundary just pushing through that area and spinning up the airs. Looking at the surface, we have a high pressure in the Atlantic, and that's pulling in warm moist air directly into the northeast coast. We have a very slow moving cold frontal boundary that's coming in from the west to the east coast, and that's going to be the main mechanism for surface lifts. Temperatures in the northeast are expected to be in the mid 90s or even higher, and dew points for some areas may see up to 70 or even close to 70. If we look at the precipitable water, we can see that there are some places that are over 2 inches and most areas are around like 1.8 to 1.9. And precipitable water is just a measurement of how much moisture is in a fixed vertical column. I'll put a chart up here to see what these numbers mean. If we look at a theoretical sounding in New Jersey, what's really important is if we follow this green line, which is the environmental dew point, as it rises up from the surface, you can see that it's getting more moist. And it's significant because when precipitation gets to the low levels, because when you get closer to the surface and it's more relatively dry, it's going to encourage more evaporative cooling. More cooling means more sinking air, and that's going to encourage a greater downdraft or greater winds today. If we look at 500 millibars or midway through the troposphere, we can see that we have pretty good wind shear, and that's going to be good to tilt those updrafts and prolong those storms. We have these little disturbances are spreading the isobars just a little bit, but that might be enough to encourage upward motion, because when you spread air aloft, it encourages flow from the bottom to fill up that space. If we look at the plains in the Mississippi Valley, it's a little bit opposite. They don't really have good wind shear. There's a little bit more in the high plains. If we look at the isobars, they spread out a lot more than what we see in the northeast, and that's going to encourage upward motion. But because there's weak wind shear, storms that do develop probably won't last that long. And that's why we have